Hi, my name is Diego Aedo. I am a PhD student and member of Núcleo Milenio Ciclo. This is my thesis work about the morphostratigraphic analysis of the coastal plain of Isla Santa María. The island is located in the southern half of the 2010 earthquake rupture area, close to this 10 meters seismic slip maximum. As we can see in this image, the island had an uplift of 2 meters during the earthquake, leaving this entire marine platform exposed above sea level. This same uplift was described for the predecessor earthquake of 1835, showing us the deformation associated with a complete seismic cycle. A very important point in this figure is that the deformation is not completely elastic and the subsidence during interseismic does not recover all the vertical deformation. This uplift would leave some geomorphological features on the island, such as beach ridges, a sequence of relict mound-shaped sediment bodies that extend parallel to the coastline, where the individual ridge correspond to the position of the old coastline. Given the geological context of the island, the deformation and land level changes associated with the seismic cycle would cause the progradation and creation of this sequence of beach ridges. So, to solve the research question, are beach ridges a continuous record of recurrent seismic uplift? We are lucky to have a modern analog of seismic deformation such as the last earthquake of 2010. Well, so we can work first with aerial photographs and satellite images to understand the evolution of the coast since 1941 to the present. Then, to understand the evolution of the coastal plain and construction of the ridges, we are going to work with GPR profiles and stratigraphy, some excavations, sedimentological analysis, and C14 and OSL dating. Preliminary results are a good number of ages based on carbon dating from polycate tubes and luminescence from feldspar and quartz grains. These dates have made it possible to establish an approximate age of the coastal plain around 4,500 years and to understand the temporal evolution of the beach ridges in relation to the available topography on the island. In these profiles, we can observe a maximum elevation of 8 meters for the oldest ridge. We have coastlines drawn since 1941 to date, which has allowed us to calculate some progradation rates during the last 80 years and measure the distance of the different coastlines with respect to 1941. Broadly speaking, it is possible to observe a break in the coastal advance trend around 2010, and this could be related to the effect of the 2-meter uplift. Another important activity is a field work during March of this year. We made some excavation to find stratigraphic signs of the change in the coastline produced in 2010. In addition, different ground control points were measured with the GPS to develop the topographic work that I will show in the next slide, and data was downloaded from a permanent GPS station installed on the island. What is currently being developed is the measurement of the horizontal and vertical changes of the coastline over the last 80 years. Using ground control points and aerial images, I am calculating topographic models from different years to understand the effect of the 2010 uplift. Finally, in collaboration with Patricio Winkler's research group, a wave model is being developed to complement this data. This is a summary of the main findings, and as a conclusion, I highlight that the study of the modern analog the 2010 earthquake, is very important for this project. So the goal this year is to develop an article about modern shoreline evolution over 80 years and vertical and horizontal changes associated with 2010 earthquake. Thank you very much.